Welcome back, everybody. Mr. Renneker here. In this next part of our remote learning lessons, we're going to start by learning about square roots. And our main objectives today are going to be to calculate square roots, and then also we're going to evaluate some different types of expressions that involve square roots. So let's go ahead and get started. So first we'll define some of the key terms we're going to use. In this lesson, it says a square root of a number is a number that, when multiplied by itself, equals a given number. Every positive number has a positive and a negative square root. A perfect square is a number with integers as its square roots. So we're going to see both of those terms here in our first example. So here we're going to find the two square roots of 49. So again, a square root is a number when multiplied by its exact self equals the given number. But here again, notice they want us to find two square roots, so a second number multiplied by itself that could equal 49. Now, many of us are very strong in our multiplication facts and probably are already aware of the fact that 7 times itself equals 49. That means that one of the square roots of 49 is 7. But there's a second one as well. And again, that goes back to our definition from the last slide. It says a square root has or is a number that when multiplied by itself is the given number, but every positive number has both a positive and a negative square root. So when we think about here, if 7 is one of the square roots, then it makes sense that negative 7 is our other square root. That should make sense because a negative times a negative, that makes a positive, so it's okay that this is positive 49, and 7 times 7 is 49. So the two square roots of 49 are positive 7 and negative 7. Now writing out directions every time of find the two square roots can be a little bit cumbersome, which is why we use some different notations for square roots that you're probably actually more familiar with than you realize. The symbol we see here is called a radical sign. It's used to represent a square root. The number that will be under the radical sign is something we call a radicand. For example, like the last example, we could have asked the same question by placing the 49 under this radical sign. Looks like a little check mark mixed with almost a division house, if you will, from earlier mathematics. This, again, this symbol with the number underneath, is asking us to find the square root of 49. Now, that radical sign can be used in a variety of different ways, like you see here. You can have a positive square root, which we see in this first box here. It says find the positive square root of 16, meaning they only want the positive square root, which would be positive 4. They can also ask you for the negative square root, we see in the second box, by placing the negative sign out in front of the radical sign. They're asking you, in other words, what's the opposite of the square root of 16, which would be negative 4. Or, for, again, using the shorthand, they can ask you for both square roots. And when they do this, you will see a positive or a plus sign above a minus or a negative sign. They're using both at the same time to simply say, give us both square roots, both positive and negative 4. So you'd be required to put that symbol before your answer. So take a look at these examples where we're going to find some square roots. Part A, notice that there is no symbol in front of a radical sign, meaning they only want the positive square root of 25. So we're asking ourselves what number times itself equals 25. And because 5 squared, or 5 times itself, because that equals 25, that means the square root of 25 is indeed 5. In part B, notice though they're asking us for the negative square root. And once you start to see fractions and decimals, you might feel a little uneasy, but there's no need here. Again, they want the negative square root, so we do need to go ahead and include our negative sign. Now we think about how do we actually multiply fractions. If we had a fraction like a over b, to multiply it by another fraction, it would just be, well, itself, a over b, and we'd multiply straight across. A times a, well, that'd be a squared, and b times b would be b squared, so we're looking for just that single a and the solitary b as well. So in other words, what number times itself equals 9? Well, that would be 3. Do the same thing for the denominator. What number times itself is 16? And that would be 4. Meaning that we should have that negative square root of 9/16, which is -3/4. You can do it with the decimal as well. And this one, you might feel like you would want a calculator handy, and I wouldn't blame you entirely for that. But I'd also like you to think of the number 2.25 in its fraction form, which at least as an improper fraction would be 225, and then look at that place value, hundredths. The reason that I'm going to ask you to temporarily view it in that way is because it helps us see that number 225. That's what we're going to want to focus on here. And say, what number times itself is 225? And with some practice and some memorization, you'll know these a little bit faster, but that number is actually 15. And while 15 times 15 does equal 225, it certainly doesn't equal 2.25, so we have to find out where to place the decimal. That's the other reason that it's helpful to picture that decimal in its fraction form, because then we can also take a look at the denominator, which describes our place value, and say, oh, well, what number times itself is 100? And that would, of course, be 10, meaning that this number 15 we have here, we should have the decimal in the correct place so that the last digit, which in this case is the 5, is in the tenths place, meaning we'd place it right between the 1 and a 5. Or in other words, it reads 1 and 5/10. Now again, they wanted the positive and negative version. They wanted both values, so you make sure you put that same symbol here. And the square root, or both square roots of 2.25 is 1.5. We're going to go ahead and take a brief pause right now, let you try a couple on your own before we go on to the second part of our lesson. And let you, ladies and gentlemen, take a look at the following problems. 1, 2, and 3, you're asked to find the two square roots, so you do need to list both separately. And then in number 4, 5, and 6, they are using the notations to ask you for specific sets of the square roots. If you'd like to try these on your own to check your understanding, go ahead and pause the video, and in just a few more moments, the answers will appear for you. And here are your solutions. Again, in 1, 2, and 3, you did have to list both of the square roots. And in 4, 5, and 6, listing specifically either the negative version, both roots, or just the positive one itself. Taking a moment just to focus on number 6, you may have needed to use some guessing and checking to help get you there, multiplying decimal values by themselves. But you will, again, feel more confident with that with some more experience. For our second objective, we're going to be evaluating expressions involving square roots, and we need to start by discussing this idea. It says squaring a positive number and finding a square root are inverse operations. And we can use this relationship to evaluate a variety of expressions and even solve equations that involve squares. Here's what this really means. If in an expression, for example, the expression listed that we were going to find the square root of 36, but at the same exact time you see it listed that they want you to square that expression, this again says that square rooting and finding the square of something, those are inverse operations. Just like in our algebra throughout the year, well, we know that multiplication and division are inverse operations. Addition and subtraction are inverse operations. Well, squaring something, that means raising it to an exponent of 2, and square rooting, those are opposites, which basically means if they happen at the same time, they eliminate each other, or in other words, they cancel each other out. So in an example like this, you would be asked to evaluate the expression, which of course means to simplify it as much as we are capable. Right here at the beginning, you see that we are asked to take the square root of 81 and square it, which as we saw just a few moments ago, those are inverses of each other. So when that happens, if we take the square root of 81, or what number times itself equals 81, that would actually leave us with 9. But that's only what's inside the parentheses here. The next thing they would ask us to do is turn right around and square that value. So 9 squared, or 9 times itself, is, well, 81 again. So a faster strategy for us will be to realize that, again, square rooting and then squaring things are just inverses, which would leave us with only the radicand itself left, in this case 81. After that, of course, we need to figure out evaluate any operations that are left. In this case, there's only one, 81 minus 5, which of course would leave us with 76. So those are the two main things that you guys are going to be doing in this section. Again, you will be calculating square roots and then evaluating a variety of expressions that also involve square roots, so be ready for that. In our next lesson, we'll also be seeing something about cube roots, which will be part of this overall lesson as well. Good luck to everybody, and I'll see you next time.